Hello, and welcome to your first ever geometry video as produced by me. Today we're going to look at conditional statements, the parts of it, and their relatives, the converse, the inverse, and contrapositive. So let's first off figure out what is a conditional statement. A conditional statement simply is a statement that is written in an if-then form. Now I'm going to come up with my own, and we're going to refer to this as we go through the notes. So my first one, I'm going to use the sentence, if it is raining, then you will need an umbrella. I have an if, I have a then. Conditional statement. Now there's parts of this. There's two parts. There's a hypothesis and a conclusion. The hypothesis, very simple, the part that follows the if. The hypothesis technically does not include the word if, but the words after it. So in my sentence, my hypothesis it is raining. There's my hypothesis. It is raining. That's it. Does not technically include the word if. So then the conclusion, of course, is the part that comes after the then. So in my sentence, my conclusion would be you need an umbrella. Again, just like the hypothesis, the conclusion does not technically include the word then, but all the words afterwards. Now, truth value. There's three possible scenarios when it comes to truth value with a conditional statement. First, how do I know if my conditional is true or false? Well, first scenario, if both the hypothesis and conclusion are true, then my sentence is true. Plain and simple. If both are true, the whole sentence is true. Second, if my hypothesis is true, but the conclusion is false, then the conditional is false. So if the first part's true, but the second part's false, I consider the whole sentence false. The third scenario is the one that gets really confusing and kind of freaks people out a little bit. If my hypothesis is false, if this part is false, then by default, I have to consider the whole sentence true. Because if this is false, I have no way of proving whether or not the whole thing is true or not. So by default, I just consider it true, and we go on from there. You'll see more of this when we get to the examples. Now, the conditional statement has some relatives. Here's my first conditional. If statement P, then statement Q. P being my hypothesis, Q being my conclusion. Sometimes you'll see this notation here. This also stands for if P, then Q. The converse is real simple. All the converse does is it takes your hypothesis and your conclusion and interchanges them. So my converse would look like this. If Q, then P. Now if you remember my first sentence up the top, my first conditional sentence, let's retype that so we can see that again. If it is raining, then you need an umbrella. So following along with this original conditional statement from the top, my converse, all I do is I take my hypothesis and my conclusion and I switch them. So the new sentence would look like, if you need an umbrella, then it is raining. Plain and simple. Just switched them. The inverse goes back to the conditional, but now it does the negation of statement P and the negation of statement Q. We talked about negations yesterday in class. So the negation for this example would be if not P, then not Q. So again, sometimes you'll see this notation here. if not P, then not Q. Remember, the tilde stands for not P, then not Q. So if I look at my original sentence, again, it goes back to the original. The opposite of it is raining, well, the opposite of it is raining is it is not raining. So if it is not raining, then do the opposite of this. You need an umbrella? You do not need an umbrella. All I did was add do not and do not need. It's not raining, do not need an umbrella. The contrapositive as I would tell some of my students, is the converse of the inverse. You're going to take your inverse, and now you're going to switch your not P and not Q. So the converse is going to look like this. If not Q, then not P. And again, here's my other notation. If not Q, then not P. So my sentence for this one would look like, if do not need an umbrella, then it is not raining. Again, all I did was I took this, if it is not raining, and switched it with, you do not need an umbrella. I just took these and switched them to get the contrapositive. Those are the three relatives of the original conditional. Let's take a look at some examples and put this into practice. Example 1. Identify the hypothesis and the conclusion of each conditional statement. I have one here. It says, if you purchase a computer and you do not like it, then you can return it within 30 days. So simply what I'm going to do is I'm going to underline my hypothesis, and I'm going to circle my conclusion. I'm going to do it right on my original sentence. Why rewrite it? It's already there. So my hypothesis, again, is all the parts after the if. So here's my if. You purchase a computer and do not like it. So underline that. Circle your conclusion. You can return it within 30 days. There is example 1. Let's take a look now at example 2. Sometimes we're given a sentence that is not a conditional sentence, but we can make it one. For example, all vertebrates have a backbone. We want to make this into a conditional statement. So, how does that start? If you are a vertebrate, then you have a backbone. If you are a vertebrate, then you have a backbone. Taken from this original sentence, it is now a conditional statement. Now, sometimes when you come up with ones on your own, yours might be slightly different than mine, because you notice I had to add a few words to make this an actual conditional statement. But as long as you have the word if, and the then, conclusion, hypothesis, you're good. Let's take a look now at example 3. We're going to look at 3 different conditional statements, determine if they are true or false. If they are false, we're going to show why they're false by giving a counter example. So, letter A. If you divide an integer by another integer, the result is also another integer. Let's do some trial and error here. 10 divided by 2 equals 5. Integer divided by an integer is also another integer. All three of these are integer. I did an integer divided by integer, I got another integer. So right now it's true, but will this ever be false? Can I divide two integers and get something that is not another integer? What if I did 1 divided by 2? What is 1 divided by 2? I have an integer divided by an integer. What is the answer? 1 divided by 2 is 0.5. This is not an integer. So my conditional statement is now false. I proved it false right here with one counterexample. Letter B. If next month is August, then this month is July. If you look at a calendar, what comes after July? August. So this conditional statement is true. Letter C. Now this is the third condition that gets a little weird. If a triangle has 4 sides, then it is concave. Look at your hypothesis. Triangle has 4 sides. Does a triangle have 4 sides? No. Triangle has how many sides? 3. My hypothesis right now is false. Since this is false, I cannot say whether or not it is concave or convex. I can't prove that. So since this is false, by default, I have to consider this true, because I cannot prove or disprove the conclusion. So this one is considered true by default. Because again, I can't determine yes or no. Last example. Write the if-then form, the converse, the inverse, and the contrapositive of the conditional statement, Olympians are athletes. Decide whether each statement is then true or false. So right now I have the sentence, Olympians are athletes. So first thing I want to do is I want to make this an if-then sentence. I want to come up with my conditional statement. So, conditional statement. If you are an Olympian, then you are an athlete. So is that true or false? If you're an Olympian, if you are in the Olympics, does that mean you are an athlete? Absolutely. You cannot be in the Olympics if you're not athletic. So this conditional statement is true. Now I'm going to write the converse of this original conditional. Now, remember, the converse, I'm going to take my hypothesis, and I'm going to take my conclusion, and I'm just going to switch them. If you are an athlete, then you are an Olympian. Now, is that sentence true or false? If you're an athlete, does that automatically make you an Olympian? I know a lot of you are involved in school athletics. You are an athlete. Are you in the Olympics? Right now, no. Maybe in the future you will be, but right now, no. So this statement is false. Next comes the inverse. Now the inverse, go back to your conditional and do the opposite of this and the opposite of this. If you are not an Olympian, then you are not an athlete. True or false? If you're not an Olympian, then you're not an athlete. So if you're not in the Olympics, you're not athletic. You're not an athlete. You don't do anything. Sit on the couch. That's false. You can be an athlete and not be in the Olympics. Just like I said previously, some of you are athletes right now, but you're not Olympians. So it's just because you're not an Olympian, does that mean you're not an athlete? No, this is false. And the last one is the contrapositive. Now the contrapositive, you're going to take your hypothesis from your inverse and your conclusion from your inverse and switch those. True or false? If you're not an athlete, you're not an Olympian. True or false? So if you're not athletic, can you be in the Olympics? This is true. And there you have it, folks. The conditional, the converse, the inverse, the contrapositive. This wraps up our lesson for today. Please go and now try and do your classwork. If you have any questions, please email me or see me after class, and we'll talk more about this. I hope you enjoyed my first video. There will be more videos in the future, and I hope the quality of them gets a little better than this one. Thank you.